Hi, welcome to Assignment 8. Assignment 8 is on the mole. We're going to review a little bit before we start about the mole from the beginning of the course. We talked about the periodic table, and we said there's two main numbers on the periodic table. There's the atomic number, which is the whole number, and there's the atomic mass, which is the decimal number. And if I want to know the mass of one atom, one molecule, or one formula unit, then I would say I have a mass that's equal to the atomic mass in AMUs. And AMU stands for atomic mass unit. We said one AMU is equal to the mass of one proton or one neutron. So if I have one atom of carbon, I can look on the periodic table and see that carbon has a mass of 12.011. We're going to round these to the 10th place. So this would mean that one carbon atom has a mass of 12 AMUs. Now, if I say an atom, I'm talking about one of an element. If I have one of a covalent compound, in other words, a compound that's made of two nonmetals, then I would have a molecule. And if I have one of an ionic compound, which is a metal and a nonmetal, then I would have one formula unit. So what is a mole? A mole is just a counting number, and it means 6.02 times 10 to the 23rd, which is Avogadro's number. A counting number is just like a dozen, because a dozen is a counting number. And a dozen is a counting number that means 12 things. So if I have 1 dozen carbon atoms, then I would have 12 carbon atoms. If I have 1 dozen water molecules, I would have 12 water molecules. If I have 1 dozen sodium chloride formula units, I would have 12 sodium chloride formula units. Just like 1 dozen means 12, 1 mole means 6.02 times 10 to the 23rd. So if I have 1 mole of carbon atoms, I would have 6.02 times 10 to the 23rd carbon atoms. If I would have a mole of water molecules, I would have 6.02 times 10 to the 23rd water molecules. If I have a mole of sodium chloride formula units, I would have 6.02 times 10 to the 23rd sodium chloride formula unit. You only want to use a mole to count something that is very, very tiny, because a mole is a big number. Now, just to give you an idea of the size of a mole, 18 grams of water would be 1 mole of water, and that would contain 6.02 times 10 to the 23rd water molecules. Actually, I found a statistic once on the internet that if you stacked a mole of Pizza Hut hand-tossed pizzas up, one on top of the other, the stack would reach from Earth all the way around the moon and almost back down to Earth again. So obviously you don't want to use a mole to count anything that's large. You're only going to use a mole when you're counting something that's very, very tiny, like atoms, molecules, or formula units. Now please note, there's no abbreviation for molecules. I know you have to write out the word molecules, but good news is you can abbreviate mole. And you can abbreviate mole by leaving off the E at the end. So if you give an answer of 5 MOL, your teacher is going to take that to mean 5 moles. If you want it to mean 5 molecules, then you have to write out the word molecules. Just like I can find out the mass of one atom of carbon using the atomic mass on the periodic table, if I use the unit AMUs, then I would know that one atom of carbon has a mass of 12 AMUs. I can also find the mass of 1 mole of an atom by using the atomic mass and using the unit grams. So 1 mole of carbon atoms is going to have a mass of 12.0 grams of carbon. 1 mole of hydrogen atoms is going to have a mass of 1.0 grams of hydrogen. 1 mole of oxygen atoms would have a mass of 16.0 grams of oxygen. Now, the number on the periodic table square, you will round to the 10th place to get the mass of a mole. Now, if I have a compound like H2O, I have 2 atoms of hydrogen, and each hydrogen has a mass of 1 gram. So that's going to give me a mass of 2 grams from hydrogen. I have 1 mole of oxygen atoms, which has a mass of 16 grams. And so together, 1 mole of water would have a mass of 18 grams. That's how I told you before that you could mass out 1 mole of water by taking 18 grams of water and putting it in a cup. So now we know how many particles are in a mole, and we know the mass of 1 mole of any element. And from that we can do a lot of different calculations, because I can know that 1 mole of water contains 6.02 times 10 to the 23rd molecules of water. And it's going to have a mass of 18 grams of water. Look at these problems, figure out the molar mass of each, and then come back and check your answers with the video. To find the molar mass of a compound, you first need to figure out how many of each element is in the compound, and then multiply that number by the molar mass of the element, which is simply the atomic mass of the element in grams. So H3PO4 has 3 hydrogen atoms. Each one has a mass of 1 gram. So that gives you 3 grams from hydrogen. There's 1 phosphorus, which has a mass of 31 grams, and there are 4 oxygens, which each have a mass of 16 grams, to contribute 64 grams to the compound from oxygen. Adding up 3, 31, and 64 gives you 102. 102.0 grams per mole is the molar mass of H3PO4. Mn2Se7, there's 2 manganese, each one having a mass of 54.9 grams, for a total mass of 109.8 grams from manganese. There's 7 seleniums. Each one has a mass of 79 grams, which gives you a total mass of 553 grams from selenium. Adding these two numbers together will give you 662.8 grams as the mass of 1 mole of manganese 7 selenide. Now, for ammonium sulfate, the formula is NH4 in parentheses with a 2 outside. Whenever you have a number outside of parentheses with a polyatomic, that number is going to tell you how many of that polyatomic you have. So for ammonium, the 2 is telling me I have 2 ammonium ions. Each ammonium ion has 1 nitrogen and 4 hydrogens. So 2 of them means I have 2 nitrogens and 8 hydrogens. The 2 nitrogens each have a mass of 14 grams, so that gives you 28 grams from nitrogen. 8 hydrogens with a mass of 1 gram each gives you a mass of 8 grams from hydrogen. 1 sulfur has a mass of 32.1 grams, which gives you a mass of 32.1 grams from sulfur. And the 4 oxygens each have a mass of 16 grams, which is going to give you a mass of 64 grams from oxygen. And I need to re-add this. So 28 plus 8 plus 32.1 plus 64 is going to give me a mass of 132.1 grams, which is the molar mass of ammonium sulfate. Now, we have talked about 2 of the 3 definitions or equalities of a mole. The 2 that we talked about is that 1 mole of anything has 6.02 times 10 to the 23rd particles. Remember, what we call particles just depends on whether we have an element off the periodic table. In that case, our particles would be atoms. We have a covalent compound, in which case our particles would be molecules, or if we have an ionic compound, and in that case our particles would be formula units. We also talked about the fact that 1 mole has a mass that's equal to the molar mass, which is the sum of all of the masses of the elements involved in a compound from the periodic table. The third definition that we won't use quite yet, but 1 mole of any gas has a volume of 22.4 liters. You can only use this fact if you have a gas. You cannot use the fact that 1 mole is 22.4 liters if you have a solid or a liquid. Now, we can write conversion factors. And a conversion factor is simply a fraction that's equal to 1. So if I say 4 divided by 4, that's going to equal 1. But I also know that 4 is equal to 2 times 2, which is also equal to 3 plus 1. I can use these in any combination to make a conversion factor and to convert from one quantity to another. So I can say 4 over 2 times 2, and that's going to equal 1. Or I can say 3 plus 1 over 2 times 2, which also equals 1. Or I could say 2 times 2 over 3 plus 1, which also equals 1. So I can use the fact that 4 equals 2 times 2, which equals 3 plus 1, in many different combinations to get a conversion factor or a fraction that's equal to 1. To solve mole problems, we're going to use a problem-solving method called dimensional analysis. And dimensional analysis is simply a problem-solving method that uses a conversion factor, which remember is just a fraction that's equal to 1, to change from one unit to another unit. We're going to set up our dimensional analysis problem by making first what we call a T-chart. In the upper left box of our T-chart, I'm going to look and I'm going to take the number and the unit that I'm given in the problem. And so this problem, I'm given the fact that I'm starting with 22 grams of argon. Whatever unit I write in this upper left box, I'm going to write the same unit in the lower right box. So I'm going to write grams of argon. And I can see from my problem that I'm trying to find out how many moles of argon I have. So I'm going to put that unit in the upper right box. Now, I can go back to the fact that I know my conversion, what mole, the definition of a mole is, and I can use this little mole map. I'm going from moles to grams, and so I'm going to use the formula mass. So if I look on the periodic table, I'm going to see that in 1 mole of argon, it's going to have a mass of 39.9 grams of argon. Grams of argon being on the top and on the bottom cancel out. And so I'm going to do the math. 22 times 1 divided by 39.9. And that's going to give me 0.551. And the unit that I'm in, since grams of argon have canceled out, I'm in moles of argon. The next one asks how many grams are in 88.1 moles of magnesium. So I'm going to do the same thing I did in the last problem. I'm going to make my T-chart. The upper left box, I'm going to put the number and the unit. So I'm going to put 88.1 moles of magnesium. I'm going to carry that unit down. And the unit I'm carrying up this time is grams of magnesium. If I look on the periodic table, I can see that 1 mole of magnesium has a mass of 24.3 grams. And so I'm going to do my math. 88.1 times 24.3 divided by 1. And that's going to give me 2,141. My moles of magnesium have canceled out, and so I'm left with grams of magnesium. The last problem asks, how many moles are in 2.3 grams of phosphorus? So once again, I'm going to make my T-chart. I'm going to put my number and my given unit in the top left box of the T-chart. So that would be 2.3 grams of phosphorus. I'm going to cross grams of phosphorus over, and I'm looking for moles of phosphorus. Well, I know my mole definition, that 1 mole is equal to the atomic mass in grams. So if I look on the periodic table, I'm going to find that phosphorus has a mass of 31.0 grams. Remember, always round your mass from the periodic table to the 10th place. So now I'm going to do the math. 2.3 times 1 divided by 31. And that's going to give me 0.0742. And grams of phosphorus have canceled out, and I'm left with moles of phosphorus. Okay, you try the problems on this page, and then stop the video, work these problems, and then come back and check your answers. There's a typo on this page that I want to clear up before we get started with the answers. On number 2, it says the compound is calcium phosphate. It should be calcium phosphite. Everything else is correct except just the naming, so it really doesn't affect the solving of the problem. Number 1, how many moles are in 68 grams of copper 2 hydroxide? So I'm going to take the 68 grams of copper 2 hydroxide, put that in my given, cross over grams of copper 2 hydroxide, and I'm going to use moles at the top. I know that 1 mole has a mass of 97.5 grams. So that's going to tell me that I have 0.697 moles of copper 2 hydroxide. Problem number 2 says, how many grams are in 2.3 times 10 to the negative 4 moles of calcium phosphate? 2.3 times 10 to the negative 4 moles of calcium phosphate would go in the upper left box. And then in the bottom right box, I would put my unit of moles of calcium phosphate. And then in the upper right box, I would put my unit of grams of calcium phosphate. 1 mole of calcium phosphate has a mass of 231.9 grams, which gives me a mass of 0.053 grams of calcium phosphate. How many moles are in 3.4 times 10 to the negative 7 grams of silicon dioxide? I would put the 3.4 times 10 to the negative 7 grams of silicon dioxide in the upper left box, carry grams of silicon dioxide over to the bottom right box, and put moles of silicon dioxide in the upper right box. Now, I know from my mole definitions that 1 mole is equal to the molar mass in grams. So if I figure out the molar mass of silicon dioxide, which comes out to be 60, and put that in front of grams, and a 1 in front of moles, That tells me that I have 5.67 times 10 to the negative 9 moles of silicon. Once again, stop the video, work these 3 problems, and then come back to the video and check your answers. How many grams are in 11.9 moles of chromium? 11.9 moles of chromium is our given, so that's going to go in our upper left box. I'm going to carry down moles of chromium, and I'm going to carry up grams of chromium. From the periodic table, I'm going to find that the definition for 1 mole of chromium is that it has a mass of 52 grams. And so that's going to give me 618.8 grams of chromium. How many moles are in 9.8 grams of calcium? In my given box, I'm going to have 9.8 grams of calcium. I'm going to carry down grams of calcium and carry up moles of calcium. And I am going to see that from my definition, 1 mole of calcium has a mass of 40.1 grams, which is going to give me a total of 0.244 moles of calcium. How many grams are in 238 moles of arsenic? My given is 238 moles of arsenic. I'm going to carry down moles of arsenic and carry up grams of arsenic. And I'm going to come out with the fact that in 238 moles of arsenic, there's a total of 17,826.2 grams of arsenic. Now you're ready to work the practice problems and the turn-in problems. You will also have a lab for this section in which you're going to need a balance, a piece of aluminum foil, a ruler, and a pair of scissors. You're also going to need some sugar and some water.